if we know the vapor density of a mixture of two gases, okay, we can figure out the composition of our mixture. And let's illustrate that with this example right here. Okay, let's just say we just have a mixture of nitrogen and oxygen. Okay, so we'll just ignore the trace components of air. And let's see if we can figure out the composition of air based on the known density of air at STP, which is 1.29 grams per liter. So let's figure out what the mole fraction of N2 and O2 are. Okay, the way we do this is first we figure out what the molar mass is, okay, of air. Now the molar mass is going to be the average given the fact that it's not going to be all N2, it's not going to be all O2, right? N2 would be 28, O2 would be 32, right? And so you, the molar mass that you can calculate based on this density is going to be a number that's between these two. It's going to be an average, but it's weighted depending on how much N2 and how much O2 you have. Okay, now if you recall, we said that the molar mass is just equal to the vapor density times the molar volume. So we're given the vapor density is 1.219 grams per liter. Okay, at STP. And we know the molar volume at STP is 22.4 liters per mole. So that cancels out liters. That gives you your molar mass, the average molar mass, which is going to be equal to 1.29 times 22.4, or 28.896, so 3 sig figs, 28.9 grams per mole. Okay, so that's the average molar mass. So that's this number that I have given here as a note for myself. That's the average molar mass. But based on that average molar mass, we can now figure out how much of it is N2 and how much of your air sample is O2. Well, look at 28.9. Let's just get a feel for what these numbers should be. Molar mass of nitrogen is 28, O2 is 32. 28.9, halfway between this is 30, right? 28.9 is around 29. So you can see the average is closer to the molar mass of N2. So you would expect that based on this information, air is going to have more than 50% N2. It's got much more N2 than it does have O2. So let's solve for the mole fractions of N2 and O2. All you really need to do is keep in mind that average molar mass is just the total mass divided by total moles. So let's assume we have 1 mole. Okay, and so if let's say X is the mole fraction of O2 and you have 1 mole of mixture, then moles of O2 would be X. Okay, and the mass of O2, so this again, let's call this X moles. Mass of O2 would be X moles times 32.00 grams per mole, right? And moles of N2, well, if the total mixture has 1 mole of gas particles, then moles of N2 would be 1 minus X moles. And the mass of N2 would be the moles of N2 times the molar mass, so 1 minus X moles times 28.00 grams per mole. Okay, so mole cancels out here. So what equation would say that the total mass is 28.9 grams? Remember, we said the mass of 1 mole is 28.9 grams. That's the molar mass. So we say then that this mass of O2 plus this mass of N2 must equal to 28.9 grams. So we say X times 32, that's 32 right there, 0.00 grams plus 1 minus X times 28.00 grams equals 28.9 grams. Right? So I can just cancel grams from both sides of the equation. I just have a simple equation here in terms of X. So 32.00X, I'm going to drop the decimal to make this easier to read. Okay, so 32X plus 1 minus X times 28 must be equal to 28.9. So now I can solve for X. And what do we get? Let's see, 32x plus, distribute this, 28 minus 28x equals 28.9. And so 32x minus 28x is 4x. And I subtract 28 from both sides. So the other side is going to be 0.9. 28.9 minus 28 is 0.9. So x in this case is going to be 0.9 over 4. And 0.9 over 4 is 0.225. So that's the mole fraction of oxygen. And the mole fraction of nitrogen will just be 1 minus 0.225, which is 0.775.